Okay, so now what we're going into float times and critical paths. I'm just going to add a little bit here, but that's okay, I'll do it in a sec. The float time of an activity is the longest time an activity can be delayed without impacting that minimum completion time. So that's what we were talking about before, that we can delay the start of an activity if it's going to take less time than everything else and still finish in time. This is what we call a float time. Now, some textbooks are going to tell you to do it this way. I'm going to say that in my examples, we're going to use something a little bit different. We're going to say the LST of the activity, subtract, and this will make sense soon, subtract the activity time, and then we're going to subtract the earliest starting time of the activity. Okay, so the LST, the activity, and the AST, and I'll explain that to you when we do it. So I'm actually going to go past these ones. Okay, so our critical path is the sequence of critical activities. Now, a critical activity is something that cannot be delayed without affecting the completion time of the project. So like I was going through in the last examples, the ones that have to be started as soon as the previous one is finished to be finished on time. Okay, so if we were looking at this one down here, we can see that they've already done the start and finish times for you, the EST and the LST. But what we're doing is we're saying here, this is going to take 2 minutes, 4 minutes, and 1 minute. So if we look at this is 2, that's 6, that's 7 minutes. If the fastest time to finish this is 7 minutes, then none of these can be delayed. Now, this one here also finishes at 7 minutes, but it only takes 4, so we get this delay of 3 minutes. So we have two different things here. We have this path here where there's no delay. This is called our critical path, meaning that nothing on there can be delayed. And we have this path here which has a float time, meaning that we can delay it and still finish in time. Okay? So let me show you how this works. So it says the activities required to complete the physics project are shown in the activity network below. All values are in hours. It says, what is the float time of activity D? So if I look at activity D here, so it can't start until A is finished. A takes 6 hours. D takes 7 hours. 6 and 7 will make 13 hours. Are we talking about hours? Yes. But I don't have to be completed till 17 hours. So it means that I can have a delay before I start D and still finish in time. So the easiest way to work out what that delay is if I have to start it by 10 hours, it's going to take me 7 hours and I need to be finished in time, okay? So how much extra time do I have? Well, if I take 17 and I take away 7 and then I take away the earliest starting time, that tells me how much leftover time I have. So I do it like this. LST, take away the activity, take away the EST. Okay, so for this one it would be 17, take away 7, take away 6. And that's going to give me 4 hours, and we call this float time. So in other words, you can do with what you want. Now, I know that some of you are going to look at this and go, oh, you can just do it from there. But that is when you've got one coming in, one coming out. When we look at more complex ones that have a few coming in there, you can't just take the numbers that are there. Okay, so I'll show you that soon. So what is the length of activity C? So if this is activity C here, what we're saying is, what is the length here? Well, if our latest starting time is 4 hours and it's going to take us to 12 hours, how long is it actually taking me? It's going to take you 8 hours to complete, because 4 plus 8 gives me my 12. Okay, so 8 hours. what is the critical path? So remembering the critical path is the path where there's no downtime. So we need to finish in 17 hours. If I go this way, 6 and 7, that doesn't add to 17. But if I go 4, 8 and 5, that does give me 17. Now the other way I can see that the critical path is there's no float times in any of these. So this becomes my critical path that has to be start and finished and started and finished and started and finished with no rest time. So that would then be written as B, C and E, and that becomes your critical path. Okay, let's look at the next one. A group of young film students are editing a short film. The activity network below shows the activities required to complete the film and their duration in hours. The students have attempted a critical path analysis on the network but have left it incomplete. What is the duration of activity F? So if we have a look at F, where's F? F is here. So what is the actual time of F? So if we have a look at the earliest starting time of F is 5 hours. The earliest starting time of G is 9 hours. So it's going to be the difference between those two is how long it's going to take to do this. So if I put what's 9 minus 5? If I put a 4 in there and I was doing my forward scan, it would be 5 plus 4, which gives me my 9. Okay, so that's going to be 4 hours. What is the EST of I? Remember, EST is the biggest number. So let's have a look. If we go to I, where's I? Here's my EST here. All right, so I've got 2 lines coming in here. Okay, so remember EST, we're going forward. So I'm going to go 9 plus 2, which gives me 11 on this line. Then I've got 17 up here coming down with a dummy, so that's going to be 17. Remember that EST is the biggest number, so we're going to put 17 in there. So 17 hours. What is the LST of A? Remember LST is the smallest. So if we look at A, we're looking at this one here. So we've only got 1 coming back in from there. So we're going to go 8 minus 4. So we would end up with a 4 in there. And what is the float time of activity E? So if we look at E, this is E here, okay? So what we want to look at is the earliest starting time of E is 5 hours. It takes 5 hours, and the latest starting time of H is 17 hours. So we would take our 17, take away our 5, take away our 5, and it would tell us that we've got a float time of 7 hours. So I'm just going to explain that again. We can start E, the earliest time we can start E is at 5 hours. It takes me 5 hours, and the earliest starting time of H is 17 hours. So I have to finish it by 17 hours. So if I take 5 and 5 away from 17, that tells me I have 7 hours of playtime. So I'm just going to write it out as I did before. LST minus the activity minus the EST. So we would go 17 minus 5, which gives me 7 hours float time. Then it says, what is the critical path? So let's go and have a look at our critical path. So I can see this one here has a bit of float. So we know it's going to go this way, right? So this one takes me 5 hours to complete. Where do I go from there? I can see that this one takes me 5 hours. So that doesn't take me to 17. This one here takes me 5 and 3, which takes me to 8. So I'm going up this way. Then I'm going to add 8 and 9, which is going to give me 17. So I'm going this way. And then my completion time is 25. So if I go 17 and 8 gives me 25. So I'm going to go that way. If I went this way, 17 and 6 does not give me 25, does it? So you're adding as you go and getting to that completion time. So for this one, we would write our critical path would be B, C, D, and H. Okay, next one. Consider the network diagram. All values are in days. Find the minimum completion time. That means we have to do an EST. As soon as I see there's a critical path, I know I'm going to have to do EST and LST because I need to find the ones that have no float time. So remember, EST is big, LST is small. Okay, so let's put our boxes in. Now, this is one where I'm going to just put one box at each vertex and show you how to use the lines, okay? So one there. Okay, so we'll start at 0 and work our way through. So we can see that A is going to take 9. It's the only one going in there, so we'll put a 9 in there. This way here, B is going to take 5. It's the only one going in, so we'll put a 5. Going down, C is the only one going in, which is 13, so we'll put 13 in there. Okay, let's keep going. If I look across here now, I've got 3 going in here, so I need to assess all 3 of them. So I've got 9 and 11, so that's 20 days. If I've got 5 and 9, that's going to be 14 days. And if I've got 13 and 4, that's going to be 17 days. So I want the biggest number there, so I'm going to put the 20 in there. Okay, so from here for G, there's only 1 going in, so it's going to be 13 and 12. So that one's going to give me 25 days. If I keep going from here, I've got 2 coming in this way, so I really need to do this one up here first. So 20, there's only 1 going in and 9, so that gives me 29. Now I need to do both of these coming through here. So I've got 25 and 7, so that's going to give me 32 days there. This way here is going to be 29 and 2, so that one's going to give me 31 days. So I'm going to be my bigger number, 32. And then I've got 2 coming into my end. So 29 and 8, which is going to give me 30, what's that, 37. And this way is going to be 32 and 5, which will give me also 37. So both of them finish at 37. Okay, so we want to work backwards now. So again, start at 37 and we'll start subtracting. Make sure you look at which ways we're going. So we're going this way, then that way, then that way, and that way. So backwards, okay? So we've only got 1 going in here, so we're going to go 37 minus 5. That gives me 32. This way here's got 2 going in. So I'm going to do 37 minus 8. 37 minus 8 is going to give me 29. And then if I go back this way, 32 minus 2 is going to give me 30. Now remember, I want to take the smallest number, so I'm going to put 29 in there. Let's keep going. We've only got 1 going back here, so we're going to go 29 minus 9, so that gives me 20 in there. And then this way, so we've got 32 minus 7. 32 minus 7 will give me 25. If I keep going now, I've got 2 going into here, so let's assess both. So we've got 25 take away 12. 25 take away 12 is going to give me 13. If I look up this way, I've got 20 take away 4, so this way is going to give me 16. Again, I want the smallest number, so 13. Let's go this way now. So if we go 20 take away 11, 20 take away 11 is going to give me 9. And now I've got 3 going into here, don't I? So you might see 3 boxes, but I'm just going to do it on the lines. So if we go 13, take away 13, we get a 0. If we go, what have we got there? 20, take away, we've got to do this one first. So 20, take away 9. What's that? 11. So I'm going to put 11 in there. And then we do 11, take away 5. That's going to give me 6 on this line. Oops, I did the wrong colour for that 0, didn't I? And then if I do 9, take away 9, I end up with a 0 there as well. And so we'll put 0 in there. Okay, so I've done my forward and backward scan. My minimum completion time is going to be 37 days. And then my critical path. Now, the easiest way to find your critical path. Now, you forgot to mention at the beginning that you can have more than one critical path. Okay, it's not always one. You can have more than one. So what we're looking for is the ones where we've picked the numbers to go in. And I'll make that make sense. So you can see that from here, we need to get to 37 hours. So if you go this way, that's going to take you 9 and 11, which is 20 hours. That is what we needed here to be able to finish in time to get to our 37. So this way here, this 20 hours is part of our critical path. So we have to go 9 hours there, 11 hours there, which takes me to 20 hours. Then I'm going over here to 29 hours. Now, where do I go from there? If I finish here at 29 hours and I add 8 more hours, I get to 37 hours. So I cannot have a break through there. So all through there, the 9, the 11, the 9, and the 8 is going to take me to 37 hours. So that's a critical path. Now, the reason I know there's another critical path is because I've got another 0 here at the beginning. Okay, so if that one's 6 there is not a critical path, but this 0 is. So now I need to go down and have a look this way. I'll do it with a different color. So this way here takes me 13 hours. Now I can see that this part here is not part of my critical path, because if I go 13 and 4, that only takes me to 17, but I needed to get to 20. So I have a little bit of a break there. But if I go this way, 13 and across with 12, I get to 25. Then I'll go across to 7, which gets me to 32. And then I go up this way for 5, which gets me to 37. So I can see that this one across here is a second critical path. Okay, so remember when we write these out, our critical path goes A, D, H, and J. And the second one is C, G, I, and L. So just making sure you're writing them out like that. Okay, we're going to draw another network. So again, let's look at what we have. So I can see A and B are my starters, so generally like this. I can see that, what have we got? Where's my finishing points? A, B, C, C, E, and E. So that looks like D and F are my finish points. So D and F are finish points. So again, that means that they're going to come in like this. There's 2 of them. There's nothing connected or sharing, so looks like it might just be this is at the start, this is at the end, and we join in between. So let's see how we go. So we're going to go A and B. Arrows, and don't forget your durations for these ones. So 9 and B is 5. Just tick them off. Okay, so I've got C coming from B, D coming from C. Okay, and remember that's a finish point. So if that's coming from B, C is coming from B, and then D is a finishing point. So I reckon it's going to look like that. And then let's look at the other ones. So E is coming from A, and then F is coming from E, so E and F. Okay, so let's do that. So let's go C coming from B. So it's going to be like this. C is 4. Let's just go straight to D coming from C to the finish point. D, which is going to be 6. And then we've got E coming from A. E from A, which is 2. And then we've got F coming from E, which is a finish point as well. F, and that one is 3. Okay, what is the minimum completion time for this project? Okay, so let's put our boxes. Minimum means only forward scan, but let's see what it says. The second part of the question says name all non-critical activities. To name the non-critical, I need to know what the critical are, don't I? So let's start 0. And this one's a pretty easy one to flow forward. 9, then 2, and then we've got 2 going into the end. So if we go up here, that's going to be 9. Keep going along, we've got 11. 11 and 3 will give me 14 on that line. Let's see what the other line is. We've got 0, 5 for B, so 5 and 4 gives me 9. 9 and 6 gives me 15. So we want the biggest time, so 15. So a minimum completion time for this is going to be 15 days. Okay. Now if we go ahead and look at the backwards scan, so we're going to start at 15 and we're going to subtract. So 15 minus 3 will give me, what's that, 12? 12 minus 2 will give me 10. 10 minus 9 is going to give me 1 on that line. So let's go the other way. 15 minus 6 will give me 9. 9 minus 4 will give me 5. 5 minus 5 will give me 0. So I can see that my critical path is this one here. So my, So my non-critical activities are going to be A, E, and F, meaning that somewhere in here I can have a delayed time because I've got a float there and a float there, and it finishes in 14 hours or 14 days instead of 15 days. So my non-criticals are A, E, and F. Okay, the float time can be described as the EST minus the LST. The amount of time that a task in a project network can be delayed without causing a delay to subsequent tasks. The latest time an activity may be started after all prior activities have been completed and without delaying the project. The sequence of activities which cannot be delayed without affecting the completion time of the project. Okay, so let's start with that last one. The sequence of activities which cannot be delayed. Now, we know that that is our critical path because that's what we've just been going on. It's not our flow time, so it's not that one. It's not EST minus LST. The amount of time that a task in a project network can be delayed without causing a delay to subsequent tasks. It's not that, it's about delaying the project. So the latest time an activity may be started after all prior activities have been completed and without delaying the project. Yes, so it's that one there, because what we're looking at is everything that's been completed before it, how long you can delay it before you start, and with making sure that you finish in time, basically. Okay. The float time of activity C in the network diagram below is, so activity C is this one. So we started at 0, it takes 2 hours, and we need to have it completed by 4 hours or days or whatever. If we don't complete it by 4, then we add 2 more, we don't finish in time, okay? So for this one, our float time is going to be the 4 minus the 2 minus the 0, so 2 hours. Okay, so I can delay this one by 2 hours and still finish in time. So if I started at 2 hours, I add 2 hours for the activity, 2 hours for this activity, and I still finish at 6 hours. The critical path of the network diagram to the right is, okay, so what we're looking at is what is the critical path. So I think we've already done this one, but let's have a look. So this one here, I can see that's 4. We've got 8s in here, so I know that I've got a float time here of 4. This way here was the one that gets to 8. We have already done this one. So here is part of our critical path. If I go this way, I can see that I've got a float between here, a float between here, so I don't want that way. There's no float here, no float here, no float here. So these are the ones that have to stay and have to be done on time. So B, C, D, F, J, which is going to be C. Okay, last one. Which one of the following statements about critical paths is true? There can only be one critical path. Well, we already know that's wrong because we just had one with 2. A critical path will always include the activity that takes the longest to complete. That's not necessarily true, because if there's only one activity on that path and it's long, doesn't mean the other one, 3 of the other ones together is going to be longer. So no. Reducing the time of any activity on a critical path for a project will always reduce the minimum completion time of the project. If there are no other changes, increasing the time of an activity on a critical path will always increase the completion time of the project. Okay, so if we reduce the time of an activity on a critical path, the project won't always reduce the minimum completion time, because it could create a different critical path, which might end up with the same completion time. So it's not that one. If there are no other changes, increasing the time on an activity on a critical path will always increase the completion time. That one is correct. All right, now you need to go and practice the text